Right now, something is racing through our solar system that has never been inside it before, and it will never come back. It's moving faster than 130,000 miles per hour. That's fast enough to cross the entire continental United States in about 90 seconds. It's not orbiting the sun. It never was. It came from somewhere outside our solar system entirely, maybe from a star hundreds of light years away, maybe from one we'll never identify, and it has been drifting through the emptiness between stars for what could be hundreds of millions, even billions of years. And then, almost by chance, it wandered close enough for us to see it. Now stop and picture that for a second. An object built from the raw materials of a completely different solar system, sealed shut in the cold dark for longer than modern humans have existed, just passing through. Close enough to photograph, close enough to study, and then gone, forever, back into the black. The strangest part of this story isn't even the object itself, it's how we found it. This is the story of 3I/Atlas, only the third confirmed interstellar visitor in the history of astronomy, and the story of how the most powerful sky mapping machine ever built, the Vera the 100th. Rubin Observatory caught a glimpse of it before the observatory had even officially finished being tested. Stop and sit with that for a second. A telescope that wasn't even fully operational yet, still running startup checks, accidentally photographed a guest from another star system without anyone realizing it at the time. That's not supposed to happen. Discoveries like this are supposed to take teams, funding cycles, years of planning. This one happened almost by accident, buried in calibration data nobody was even looking at closely. And yet, there it was. Before we go further, if you're new here, this channel is all about the biggest discoveries in space and science, broken down without the jargon, so if that sounds like your thing, go ahead and hit subscribe, because we're about to get into exactly how scientists caught this thing, what it's actually made of, why some very credible scientists publicly disagreed about what it could be, and why a retired astronomer's decades-old idea ended up becoming humanity's best chance at catching the next interstellar wanderer before it slips away. Let's start with where this story really begins, not with the object, but with the telescope that found it. The Vera the 100th. Rubin Observatory sits on top of Cerro Pachon, a mountain in Chile chosen because the air there is dry, dark, and unusually still, perfect conditions for staring deep into space without atmospheric interference blurring the view. The observatory is named after Vera Rubin, an American astronomer who, back in the 1970s, discovered something that shouldn't have been possible. She was studying how fast stars orbit around the edges of spiral galaxies, and the numbers didn't add up. Stars near the outer edges of galaxies were moving far too quickly to be held in place by the gravity of all the visible stars and gas combined. By all the normal rules of physics, those galaxies should have been flying apart. They weren't. Something invisible had to be holding them together, some form of matter we couldn't see, couldn't detect directly, but whose gravitational fingerprints were everywhere. That invisible substance became known as dark matter, and Rubin's careful, painstaking measurements remain some of the strongest evidence we have that it exists. She once summarized her entire life's work with a line that still gives scientists chills. In a spiral galaxy, the ratio of dark to light matter is about a factor of 10. That's probably a good number for the ratio of our ignorance to knowledge. Decades later, an entire observatory was built and named in her honor, a machine designed specifically to hunt for the invisible, the unexpected, and the previously unknown. The original mission for this observatory was almost absurdly ambitious. Most telescopes point at one tiny patch of sky and stare for hours, gathering as much light as possible from a single target. Rubin was built to do the opposite. Instead of staring, it sweeps. Instead of one target, it captures the entire visible southern sky, again and again, every few nights, for 10 straight years. To do that, engineers built it around the largest digital camera ever constructed for astronomy, a sensor with more than 3,000 megapixels, roughly the size of a small car, capable of capturing so much detail that a single photograph could resolve a golf ball from 15 miles away. Every few nights, the telescope repeats its sweep of the sky, comparing each new image against the last, hunting for anything that has moved, brightened, dimmed, or exploded. Scientists call the resulting project the Legacy Survey of Space and Time, essentially a continuously updating movie of the entire universe, built one image at a time. That was the plan: map everything, catch anything that changes, find exploding stars, colliding neutron stars, hazardous asteroids on collision courses with Earth, and maybe, if the odds ever lined up, catch something that came from outside our solar system entirely. Nobody expected that last part to happen this soon. The observatory wasn't even finished being calibrated. Because here's the twist nobody saw coming. Rubin Observatory caught its first interstellar object before it had officially opened for business. During the summer of 2025, engineers were still running test observations, essentially warming up the telescope's systems, checking that the massive camera, the mirrors, and the software all worked together correctly. These images were never meant to be real scientific data. They were housekeeping, background noise, the digital equivalent of clearing your throat before a performance. But when astronomers later went back through those early calibration images, comparing them against a newly discovered object, they found something remarkable. On July 1, 2025, the Atlas Survey Network, an independent asteroid tracking system, spotted a faint, fast-moving object that didn't match any known comet or asteroid. When scientists cross-referenced that discovery against Rubin's earlier test images, they found a match. Rubin had unknowingly photographed the same object days before its official discovery, without anyone realizing what they were looking at. Astronomers call this a precovery, like discovering an old photograph that proves something important happened earlier than anyone realized. In this case, those extra days of data let scientists calculate the object's path through space with far greater precision, and that path told them everything they needed to know. Because here's the first real discovery, the moment that changed everything. This object's trajectory wasn't a closed loop. It was a hyperbola, an open curve that swings in once and never returns. Every planet in our solar system, every asteroid, every native comet, moves in a closed ellipse, locked in permanent orbit around the sun. This object wasn't locked in. It came from outside our solar system. It's making one single pass by the sun, and then it is leaving forever. It will never come back, not in 1,000 years, not in 1,000,000. Why should that matter to you? Because in the entire recorded history of astronomy, this kind of object has only been confirmed 3 times, ever. Oumuamua in 2017, Borisov in 2019. And now 3I/Atlas, the I standing for interstellar, the 3 inches meaning it's only the 3rd one humanity has ever confirmed. You are alive during the tiny sliver of human history when we finally built the technology sensitive enough to notice these visitors passing through. For nearly the entire span of human civilization, objects exactly like this one could have drifted silently through our solar system, and not a single person would have ever known. But the discoveries didn't stop at confirming where it came from. That's actually where the story really starts to pivot. The next major turning point arrived when telescopes, including powerful infrared instruments capable of detecting heat and chemical signatures, started analyzing what 3I/Atlas was actually made of. And the results were genuinely strange. Comets native to our own solar system are typically dominated by water ice. When they get close to the sun and start heating up, they release mostly water vapor, which is what creates that glowing, streaking tail. 3I/Atlas broke that pattern almost immediately. Observations found it releasing enormous amounts of carbon dioxide gas, with some research teams reporting a carbon dioxide to water ratio far higher than almost any comet ever studied from our own solar system. In plain language, this object was built differently, from different ingredients, under different conditions than the comets we're used to seeing. Scientists believe that difference points to something profound about where 3I/Atlas actually came from. It likely formed in an extremely cold, distant region of its home star system, a place cold enough that carbon dioxide could freeze solid, but possibly too far from its star for large amounts of water ice to have survived the same way. In other words, this isn't just a rock passing through our neighborhood. It's a sealed chemical time capsule from another solar system entirely, one that formed under conditions completely unlike our own, locked shut for potentially billions of years, and it just cracked open in front of our telescopes for the very first time. Let that land for a second. We are getting a direct sample, not through a billion-dollar spacecraft mission, not through a decade of planning and engineering, but simply by watching patiently of the raw building blocks that formed a planetary system that isn't ours. Nobody built a rocket to go get this data. It came to us. Now here's where the story gets genuinely uncomfortable, and where real human disagreement enters the picture, because not every scientist agreed on what this object actually was. Harvard astrophysicist Avi Loeb, who had previously made global headlines by suggesting the very first interstellar object, Oumuamua, might not have been entirely natural, raised similar questions about 3I/Atlas. He pointed to its size, its unusual trajectory, and its strange chemistry as reasons to at least seriously investigate and rule out the possibility of an artificial origin, rather than immediately assuming it was just a comet and moving on. That sparked a wave of public fascination and heavy media coverage. It also triggered significant pushback from much of the broader astronomical community, who argued that everything actually observed about 3I/Atlas, its outgassing, its chemical composition, the shape and behavior of its tail, and the way it brightened as it approached the sun, was fully consistent with natural cometary behavior we've documented before, just coming from an object with an unusually distinct chemical origin. This is real tension inside real science, not manufactured drama for a video script. Actual disagreement among actual credentialed experts playing out in research papers, conference talks, and public statements about how confident anyone can responsibly be, how quickly, based on limited data from an object that is only observable for a matter of months before it disappears into deep space forever. If a story like that grabs you, the idea of scientists racing against a closing window, debating incomplete evidence, trying to reach the right conclusion before the evidence itself vanishes, sit with that tension for a second, because it's rare and it's real. And if this is the kind of deep dive you come to this channel for, drop a comment telling me which side of that argument you land on, the camp that says keep an open mind about anomalies, or the camp that says extraordinary claims require extraordinary evidence. The discussion in the comments on this topic gets genuinely fascinating, because here's the part most headlines leave out entirely: none of this was easy. Behind every article about 3I/Atlas, there were teams of astronomers working on brutally compressed timelines because interstellar objects don't wait around for anyone's schedule. Once 3I/Atlas was confirmed, researchers around the world had a matter of months, not years, to point every available telescope at it before it swung too close to the sun's glare to observe, disappearing from view for weeks with no guarantee of what state it would be in when it re-emerged on the other side. There was no guarantee it would survive that close pass to the sun without breaking apart. There was no guarantee the data collected would even be good enough to answer the biggest open questions. Teams had to prioritize which telescopes got which nights, argue over limited observation time, write and revise papers under real deadline pressure, and accept that whatever they failed to capture in that narrow window might be lost to human knowledge permanently, because this object is genuinely never coming back. That's the quiet reality behind interstellar science. It isn't slow, careful, and stately. It's a scramble against a clock that nobody on Earth controls. And this is happening right now, in a very literal sense. As of today, Rubin Observatory has moved well past its early testing phase and is deep into full operation of its 10-year legacy survey of space and time. Astronomers are still combing through the 3I/Atlas data collected over the past year, refining their models of its composition, comparing it directly against Oumuamua and Borisov, and using everything they've learned as a blueprint for catching the next one, because there will be a next one. That's the part that should genuinely excite you. 3I/Atlas wasn't a fluke that Rubin happened to stumble into during an unfinished test run. It was a preview of what's coming. Scientists who helped design Rubin's survey strategy have estimated that once the observatory is running at full capacity for its entire planned mission, it could detect somewhere between several and several dozen new interstellar objects, a staggering leap from the total of just 3 we've confirmed across all of recorded human history combined. And there's one specific hard date worth marking down right now. Rubin's legacy survey of space and time is scheduled to run for a full 10 years, with the complete survey currently planned to conclude around October of 2035. When that mission wraps, scientists expect to have entirely rewritten our catalog of the solar system's outer visitors, not just interstellar objects, but millions of previously undiscovered asteroids, comets, and moving objects of every kind. That date isn't speculation or marketing. It's the actual planned endpoint of the most ambitious sky survey ever attempted by humanity. And by the time it arrives, our current tally of 3 known interstellar visitors may look almost quaint by comparison. Let that sink in for a moment. Because if you zoom out far enough, this story stops being about one strange icy object and becomes something much bigger. For nearly all of human history, we believed, reasonably, based on everything we could observe, that our solar system was a closed, isolated system. The sun, the planets, the asteroid belt, the occasional native comet, all orbiting together in one neat, self-contained loop, sealed off from everything else. Oumuamua, Borisov, and now 3I/Atlas are proof that our solar system was never actually sealed at all. It's more like a house with the windows left open, and every so often something from far outside drifts in, passes silently through the living room, and drifts back out into the night, carrying with it a fragment of a world we will likely never visit, built around a star we may never even be able to identify. We are, quite literally, catching physical pieces of other planetary systems flying straight through our own, for free, without launching a single spacecraft, simply by being patient enough to build a machine that watches the entire sky, every single night, and by naming that machine after a woman who spent her entire career proving that the universe holds far more than what we can immediately see with our own eyes. And yet, for everything we've learned about 3I/Atlas, its blistering speed, its one-way trajectory, its unusual and telling chemistry, the biggest questions surrounding it remain completely open. We still don't know, with any real certainty, how many other star systems it may have drifted past on its journey here, or exactly how long it has been traveling through the emptiness of interstellar space before it ever reached us. We don't fully understand why its chemical composition looks the way it does, or precisely what that composition reveals about the environment where it originally formed. And most tantalizing of all, we have no idea what the next interstellar visitor will look like, when it will arrive, or whether the very next pre-covery image is already sitting quietly inside Rubin's data archive right now, waiting for someone, somewhere, to finally notice it. Somewhere in the mountain of images Rubin generates every single night, there could already be a 4th interstellar visitor hiding in plain sight. Nobody knows. Not yet. If this kind of story pulls you in, the idea that the universe keeps sending us messengers we almost miss, caught by machines running what were supposed to be routine test runs, subscribe and turn on notifications, because this channel covers exactly this kind of discovery as it happens, in real time. Drop a comment with what you personally think 3I/Atlas actually is, or what you think the next interstellar visitor might reveal about the galaxy around us. Share this video with someone who needs to hear that a piece of another solar system just flew silently past our own. Then stick around, because in the next video, we're going all the way back to where this entire mystery started, Oumuamua, the very first interstellar object ever confirmed, and the one scientists still can't fully explain.